At the bottom down here, we need to go ahead and simplify this. You notice that 3 is a common factor here. So let's go ahead and pull that out. You'll now notice with what's inside your parentheses here, that's one of your Pythagorean theorem identities. Because you know 1 plus cotangent squared alpha is equal to your cosecant squared alpha. If you subtract your cotangent squared from both sides, you get a cosecant squared alpha minus a cotangent squared alpha. That's what this is. So the whole inside here simplifies down to 1. 3 times 1 is 3. We now need to simplify this. A lot of times it's easier to just go ahead and turn everything into sines and cosines. Not always, but a lot of times that works. So we'll replace your cosecant with 1 over sine. Replace this cosecant with 1 over sine. You'll now notice we have fractions within a fraction. So we'll look here and we'll have 3 denominators. We find our LCD. That LCD ends up being sine squared. So I'm going to multiply the top by sine squared and the bottom by sine squared. I then need to go ahead and distribute this through to each one. So my sine squared times my 1 over sine gives me a sine squared over sine, which is sine. My sine squared times my 1 is my sine squared. Then I need to go ahead and distribute through on the bottom. My sine squared times 1 over sine squared is 1. Sine squared times 1 over sine is sine squared over 1, or just sine. You'll notice that we now have a common factor on the top. We could pull out sine. You pull out that common factor. You still have the bottom. You'll now notice that you have a sine plus 1 on the top, and the bottom, they're going to drop out, giving you just sine. We need to rewrite our tangent in terms of sines and cosines to be able to get our tangent only in cosines. Well, we know that tangent, sine over cosine. We need to go ahead and simplify this because we're not done, because we have a sine in the top. We need to eliminate that sine. We need to somehow replace it with a cosine. So that's where our other Pythagorean theorem identity comes into play. We'll need to go ahead and solve this for sine. So we'll subtract the cosine squared from both sides, and then we'll have to take our square root. All we're going to do then is go ahead and take this right here and substitute it in. And that's what we're going to get for our answer. We now have our tangent written only with cosines. We need to simplify the left side to show that it simplifies down to the right side. We have a cotangent. Cotangent's cosine over sine. Tangent is sine over cosine. Well, our common denominator is sine times cosine, so I got to multiply the top by cosine here and the bottom by cosine. I then need to go ahead and multiply the other one to get that common denominator. And a cosine times cosine is a cosine squared. Sine times sine is a sine squared. You should realize that this is one of your Pythagorean theorem identities. Cosine squared plus sine squared equals 1. The bottom is just your common denominator. The top is 1. We can now go ahead and write this as two separate fractions. So it's 1 over your sine times 1 over your cosine. Well, 1 over sine is your cosecant. 1 over your cosine is your secant, and that's what we were trying to get to. Over here on the far right, we're going to want to just distribute through. Yes, you could turn it all into sines and cosines, but this one's pretty easy to distribute through. If you take your tangent times tangent, you get a tangent squared, theta. Tangent times cotangent, they're reciprocals. Whenever you multiply reciprocals together, you get 1. Because think of 2 over 3 times its reciprocal of 3 over 2. You multiply, you get 1. Now, that's one of your Pythagorean theorem identities. Tangent squared plus 1 is your secant squared. We need to go ahead and write our 6 trigonometric functions for this one here. We know our cosine is 1/2. So we know secant then is the reciprocal of 2. We know cosine's positive. Cosine deals with x, so that means it's first or fourth quadrant. Sine is negative. Sine deals with y, so we know that that has to be the third or the fourth because y is negative in those quadrants. Well, it only overlaps then in the fourth quadrant, so we got to draw a right triangle in the fourth quadrant. You come out from the origin, make a right angle to the x-axis, always the x-axis. Your angles at the origin then, you know cosine is adjacent of 1 over hypotenuse, so you know your side adjacent to your angle is 1, your hypotenuse is 2. You can then use your Pythagorean theorem identity to get the third side. You'll notice the third side is negative because it's going down in the negative direction. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. Then we just have to do our reciprocals. The reciprocal of tangent would be 1 over a root 3, negative, but then you got to rationalize that. Same thing here. You do the reciprocal of that one, but then you'll have to rationalize it.